In this problem, we're looking for which one of these tables represents an exponential relationship. Remember, an exponential equation would imply that your variable x is in the exponent of a power. For example, the general format might be y equals a multiplied by b to the power of x. So that's kind of what we're looking for. So first, taking a look at option number 2 here, that one is an example of a linear relationship or a linear pattern. And I know that's the case because it's following a constant pattern as x decreases by 4 each time, y increases by 1 each time. It's constant. Our third graph here, we can see that the pattern is actually pretty easy to spot. You are squaring every single x term to get the y value. 0 squared is 0, 1 squared is 1, 2 squared is 4, and so on. So the equation there is literally just y equals x squared. And that's not an exponential relationship. That is, in fact, a quadratic. Moving on to the fourth one here, this is actually very similar to the third one, except that here we're dealing with the equation y equals x cubed. And that's because 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. So that's an example of a cubic function. So that leaves us with the first one. And this is definitely an example of an exponential relationship. In fact, the equation they're using here is 16 multiplied by 1/2 to the power of x. And I know that's the case because if I were to look backwards a little bit, if x was 0 and following this pattern, you see how going upwards it doubles each time. Our y value would be 16. So think of this as our initial value being 16. It's decreasing at a ratio of 1/2. We're multiplying by 1/2 each time. And our exponent is our x. So that is a prime example of an exponential relationship. All right, that's all for this video, and thanks for visiting JD's Preparation.